Hello students, in this video we are going to learn about diffraction of light at a single slit. Diffraction is a phenomenon of bending of light around the corners of small obstacles or apertures and spreading of light into its geometrical shadow on the screen. It is similar to interference. In interference, superposition of waves originating from two different wavefronts. But in diffraction, there is also superposition of secondary waves originating from the different parts of the same wavefront. Here is a diagram. There is a source. It is illuminated by a monochromatic light of wavelength lambda. And here is a converging lens and forming a parallel beam, and this parallel beam forming a plane wavefront that is incident on the slit AB. The slit AB has a width A and it is a source of secondary wavelets, and these secondary wavelets spread in all directions when it is reaching the screen here. And it is converged, the secondary wavelets are converged by another lens here and forming certain pattern on the screen. At the center it forms central maxima and the secondary maxima and so on as shown in the graph. Here this is the intensity distribution. And here this slit AB is having the center point C and there is a normal drawn AN and here is a path difference P. P is equal to lambda equivalent to wavelength of light. There is a reference point taken on the screen. We have to find out expressions for the maxima or minima formed at this reference point. So here we have written the path difference P is equal to, we have taken BP minus AP that is equal to BN, the small difference on its path that is equal to AB sin theta, where AB already is equal to A, therefore it is A sin theta. Now we have to find out the positions of minima. So we have taken here the same slit AB when it is divided into two equal parts, forming that the upper part is AC and the lower part is CB. For every point in the upper half of AC, there is a point in the lower half. Therefore, these wavelets from each half reach the point P always in opposite direction. When you look at this, always in the opposite direction. So these waves will form a destructive pattern at the point P, forming a minima on the screen. Therefore, we have to calculate what is the position of minima which is formed due to splitting this slit into two halves. So, we are writing here for the first dark. For the first dark fringe, what is the formula here? A sin theta 1 that is equal to lambda here, and for the second in the similar way we can also write for the second dark fringe. For the second dark it is going to be A sin theta 2 that is equal to 2 lambda, and in the similar way for the third dark fringe at the point P it is going to be 3 lambda, for the fourth it is going to be 4 lambda. Therefore we can write here for the nth dark fringe we would have the formula A sin theta n that is equal to n lambda. This is a formula for nth dark fringe which is formed at the reference point, where n is equal to, we can take 1, 2, 3 etc. the value of n. Therefore, we can also take that for the direction of various minima formed at the point P, the direction for the smaller values we take here sin theta n is equal to theta n itself. Therefore, from the above equation we can write here A sin theta n is equal to n lambda. Therefore, theta n can be written here as n lambda by A. Therefore, we can also say that this small angle is taken by considering that lambda is also much smaller than the width of the slit AB. Therefore, we write here lambda is much smaller than A value. So, this gives you the direction of various minima. Direction of various minima formed on the screen. That is what shown here. In the similar way, we also understand that the position of secondary maxima, if you want to understand at the reference point P, what is the position? How can we get the secondary maxima formed on the screen? That is possible when the slit is divided into three equal parts. AB is divided into three equal parts. Let the point P is so located that P is equal to 3 lambda by 2. That is, the slit AB is divided into 3 halves and the path difference between the first 2 halves will be here lambda by 2, as we have discussed here. First half 1 and 2 will have lambda by 2. The wavelets from first 2 halves form a destructive pattern because they always overlap at the point P in the opposite phase. So here 1 and 2, the 2 halves will anyhow produce a destructive pattern and the third half is alone left. Therefore, somehow the wavelets originating from the third half will form a constructive pattern at the point P. But anyhow, its intensity is much less than that of the central maxima. You can see here the secondary maxima that has an intensity much less than the central maxima. It is due to only the 1/3 of this slit, the waves originating from this portion that form a constructive pattern. The remaining 2, first and second halves, will form a destructive pattern and hence intensity is less. In the similar way, you can also see the intensity of second secondary, third secondary maxima will have much less than that of central maxima. Therefore, we can also write here what is the position of first secondary maxima. What is the formula for this? We write here A sin theta 1 dash. Here we have taken theta 1. Here theta 1 dash we are taking, that is equal to 3 by 2 lambda, because we have taken path difference is equal to 3 times of lambda by 2. In the similar way, if I want to write for second secondary maxima, A sin theta 2 dash, that is equal to 5 by 2 lambda. In the similar way, for the nth maxima, secondary maxima, if you want to write, it is going to be A sin theta n dash, that is equal to, because it is 3 by 2, 5 by 2, 7 by 2, etc. Therefore, 2n plus 1, we have taken lambda by 2, and we also write where n is equal to 1, 2, 3, etc. in this formula. Now, this is a formula for nth secondary maximum when the slit is divided into 3 halves and forming secondary maxima at the reference point P on the screen. In the similar way, we can also write what is the direction of various maxima formed on the screen. The direction we can write here. Here also sin theta n dash is approximately equal to theta n dash for the smaller value, as we have already taken here. This lambda is much less than the width of the slit. Therefore, we write theta n dash is equal to 2n plus 1 lambda upon 2a. This is also very important expression to know what is the direction of various maxima formed on the screen. We understand that when theta is equal to 0, there is a broad central maximum. You can see this also. It is a graph drawn between intensity and the angle theta. When theta is equal to 0, there is a broad spectrum of central maximum. And when theta is equal to plus or minus, when theta is equal to plus or minus n lambda by a, we get here there is a minima formed. There is a minima, but here we understand n is not going to be equal to 0. But when theta is equal to plus or minus 2n plus 1 lambda by 2a, we get there is a maxima formed on the screen. These are the conditions to understand here. But we understand the intensity of secondary maxima is always less. Okay, when n increases, it decreases. When n value increases, then the intensity decreases. The intensity of first secondary maxima, this is a first secondary maxima, is just 4% of the central maximum. If you see, this is a first secondary, second secondary, third secondary, and this is the central. So this is going to be 4% of that central maxima. I hope you understood the phenomenon called diffraction at a single slit and the formation of the diffraction spread on the screen very well. Thank you for watching.